Let's get some practice with function notation when we have the square root function. So g of x is the square root of 6 minus 2x. So for g of 3, I'm taking 6 minus 2 times 3. I'm putting in 3 in place of x. This is going to give me 6 minus 6. But the square root of 6 minus 6 is the square root of 0, which is just 0. We can have 0 under a radical. That is something that is allowed. But when we take a look at g of 4, on the other hand, this is going to produce 6 minus 2 times 4, which gives me the square root of 6 minus 8, which is the square root of negative 2, which we cannot have. And right now we're going to call this undefined. However, we will take a look at what we can do when we get into the complex number system as far as negatives under the radical. But when we're dealing with these real numbers, this is undefined. So now I'm going to take the square root of 6 minus 2 times negative 4. And this is equal to the square root of 6 plus, notice the minus minus becomes plus, so I've got the square root of 6 plus 8, which is equal to the square root of 14. Now I always want to ask myself if there's any perfect squares that come out of root 14 or whatever I'm left with under the radical, because I always want to simplify. In this instance, there are no perfect squares, so we will just leave this as root 14. But taking a look at this last one, I've got the square root of 2w for x. So I need to do 6 minus 2 times 2w in place of x. So this is going to be equal to 6 minus 2 times 2 just gives me 4w. And there's nothing else I can do with this here. I'm not going to break it apart. I'm just going to leave this as the square root of 6 minus 4w.